The power scenario has the power scenario usage in watts, which is an attribute that is derived, and it's driven by the power scenario power usage roll-up opaque behavior. And so if we look at the opaque behavior, it's using a variety of the special operations that Magic Draw provides, including mapping operations, and again, it'll reward study beyond the scope of this video and this tutorial. I'll be happy to talk with you later about it, but it's well formed, and it's using a variety of the operations provided inside Magic Draw. But again, fundamentally, it's taking in the scenario as its starting point, returning the power usages. So notice it's anything that were the source of a directed relationship. We only return the power usages, and then the mapping operation is a nested operation that then goes ahead and multiplies all this out, and then it gets reduced with this summation operation, and that takes care of all this for us. Again, I intend to rework this with the sum product function. I didn't have time to get it working now. But fundamentally, this will automatically roll up the power demands based on the creation of the power usages. So if we look at this dependency matrix here, this is basically showing us all of the power usages that connect a given power scenario. So this is a use case with the power scenario stereotype applied to the part properties. Now we'd like to point out a nice feature here in this latest version of Magic Draw is that we now can change, oh, sorry, the wrong spot. It's in the query here. We now can drive the row and column with queries, and notice when we hit this, we can choose to show it in terms of containment or structure. And so by toggling this, notice if I do this, it only shows me the part properties. I lose a lot because I scope this based on the example system. If I go ahead and toggle this and let me see the structure, it lets me start it at a given block, and then it drills all the way down and lets me see the structure. So this basically lets us mirror the structure tree in a dependency matrix, which is hugely powerful. So note we've then again created all these relationships between the power scenarios and the given part properties. So if this relationship exists, it means that that part is turned on. I can double click here and create them because I've set this column to row, which means a simple double click creates them. And if I wanted to change the power usage value, I could come here to tags and change the usage factor, like in this case to 0.5. And now that particular part will be used at half power. So if we look at the power usage table here, notice our usage factor is a half, and we should be able to look all the way across this and make some judgments about what's happening, just to double check it. So there's 4 of these, times a half is 2, 2 times 5 is 10, and notice our electric usage is 10. So this all multiplies out. Notice that the electric usage here is just a custom column. Again, it's often a tough battle between what do we put just in a table and what do we make into a property that's useful everywhere. So if I have information that's really only relevant under certain circumstances, I will tend to make it a custom column in a table rather than load the model up with a lot of customization and derived properties. So in this case, this is just multiplying the 3 things. And again, we're using the first to convert the meta chain into a number. So this is the usage factor times the upper, or you can use lower. I tend to prefer using upper, but that automatically is 1 even if the multiplicity is unspecified, which is a nice feature. And then this last value is the electric power usage carried by the physical block. And so again, that's all that. The scenario usage is a custom column that's returning the value from the power scenario that the meta chain point, or the power usage points to. So we use a meta chain to return that value. So that is being driven by the customization. And then the percent contribution is just dividing this column by that column. So my contribution by the total to get the percent contribution. So again, there's lots of really cool things we can do here just as a quick double check and as an error check. So this is a quick and dirty, fast way to collect subject matter expertise. You could have your whole bill of materials here. You could collapse this, focus in on a certain subsystem. Is this on or off in this scenario? we're going uphill, is the air conditioning on in the summer, whatever it may be. But this gives you a very rapid way to roll all this up and do a lot of analysis, and it doesn't require the use of state machines and a lot of executability. So again, there's a time and a place for these quick and dirty back-of-the-envelope calculations.